This is video 10 for College Algebra, and today we're going to be analyzing graphs of functions. So first of all, a zero of a function. It's the x values where f of x equals 0, okay? So we're going to set all of our equations equal to 0 to find our zeros. A lot of times zeros can also be called roots or solutions. Okay, so you'll see all three of those names interchangeably. So the first one, we've got a quadratic, so we're going to be finding two zeros. Okay, and remember I like to do my x factoring. So we're going to be multiplying to negative 30 because we're multiplying this 3 times our negative 10. And adding to positive 1. So we start off with a 3x and a 3x because that's how our equation starts off. And then I'm going to think of two numbers that multiply to negative 30 and add to 1. So that would be negative 5 and positive 6. Now my negative 5, my 3x minus 5, I cannot reduce that at all. That's the way it is. But my 3x plus 6, I can divide by 3 and I get x plus 2. All right, and so from there I can write these as factors in my equation. This would be 3x minus 5 and x plus 2. All right, so from there we use the zero product property where we set each factor equal to 0 and then we solve. All right, so we've got our two answers, x equals negative 2 and x equals 5/3. All right, for our next one, again, we put our function equal to 0. To get rid of my square root, we are going to square the function. So we square both sides. All right, and then I get x squared equaling 10. So x equals plus or minus the square root of 10. So those are my two answers. Now for my third problem, again we set equal to 0, and since we have a fraction equaling just another fraction, because remember we can write 0 as 0 over 1, we can cross multiply. So we get 2t minus 3 equals 0. That's what happens when I do my cross multiplication. And we get 2t equals 3 and t equals 3/2. Make sure when you have radicals that you plug those in to check your answers. For example, if we gotten t equals negative 5, that would have not been a solution because I would have been dividing by 0 if I plugged that back in. All right, so moving on, talking about some graphs. So this could be just any type of graph, and we've got different intervals. So we've got decreasing intervals, intervals that are constant, and increasing. Okay, and so we're going to be looking at intervals where these two graphs are increasing, decreasing, and constant. So let's first focus on this first function, that parabola. So sometimes it's easy to kind of color code a little bit, or I like to kind of draw arrows onto my functions thinking, okay, how is this going? And I always draw them left to right. And it kind of helps a little bit figure out how's my function going, okay? And you always go left to right. So it is increasing over 2 intervals, and that would be from negative infinity all the way to -1, and then we use this union, and that connects with 1 all the way to infinity, and we use those x values because we're just looking from left to right. All right, it's decreasing just this middle section, so that would just be from -1 to +1. And it is not constant ever. Okay, looking at our next problem. Increasing, that would be this first section. And this would be from -infinity to 0. It's decreasing right along this side, so that would be from 2 to infinity. And constant right here in the middle, it's constant from 0 to 2. Okay, and again, we're looking at just our x values. All right, now looking at our relative minimum and maximum. Those are points where the function changes from increasing to decreasing, or constant, or vice versa. So we could have 3 relative min-maximums at these 3 points. Because it's obviously not the maximum, but it is relative to its points around it. So on a graphing calculator, you'll hit y equals, and then you'll hit your graph, and then second calc, and then you arrow down to your minimum or maximum value. So go ahead and type in the first equation into the y equals of your graphing calculator. And we're going to go through the steps of finding that relative minimum or maximum. All right, so we look at the graph, and it looks like we're going to have a relative minimum, or here it's just a minimum. And so we look at the graph, we hit second calc, and we're going to go down to minimum. And so now this says left bound. So that means we want to be on the left side of our minimum, which is right here. Okay, and I call this guy a little frogger. He looks like a little flashing frogger. So I put my frogger guy really close to that minimum, but not on the minimum. And I press enter. Then it says right bound. So you're going to move your frogger over to the other side of your minimum and get it as close as you can, but not on the minimum, and press enter. Now the closer that you are, it will give you a more accurate answer because this is an average. And so it asks you, do you want to guess at this point? You say yes, and then it tells you your minimum. All right, so my minimum here is .667 negative 3.333. And that is our minimum. Okay, and now we're going to do it for our next example. So negative 4x squared minus 7x plus 3. Okay, and we're going to look at the graph so we can see if it's a minimum or maximum. We're going to second calc. This is a max. And we got to move our frogger to the left side. So I'm going to press enter, move it to the right, press enter. And my maximum is negative 0.8756063. 3. Okay, you can also find your minimums and maximums using Desmos. All right, next one, we're going to find the average rate of change. Okay, we know how to find rate of change, but sometimes when we're dealing with non-linear functions, we can't find the exact rate, so we're just finding the average. All right, so we're going to take the difference of two x values, the plugged in to the equation, divided by just the difference of the values. So change in y over the change in x. So for this one, if we were going to find the average rate of change from -1 to -2 of our function x cubed minus 3x, we are going to plug in that value into the function. So we'd say f of -2 minus f of -1 divided by -2 minus -1. Don't forget that minus a negative. All right, so we're going to plug -2 into our equation. So -2 cubed minus 3 times -2 minus, and then we do that with our -1. Okay, and then this is all divided by -2, and let's simplify this just to -2 plus 1. All right, and so this actually simplifies to just 4, or -4, or -4 over 1. All right, the last thing we're going to talk about are even and odd functions. An even function, if I plug in a -x, I'm still going to get the same function out. Okay, it's symmetrical to the y-axis. So if I have a dot over here, the dot's going to be on the same side. Same with my x. The x will be transferred over to the same side, just over that y-axis. Okay. With our odd functions, if I plug in a -x, it's actually going to change my entire function negative. So it's going to flip all of my signs. And this is symmetrical to the origin. So they flip over that origin. We've got two examples determining whether or not the function is even or odd. So we're going to plug in a -x and see what happens to our function. So if I plug in a g of -x, that'd be -x to the 4th power minus -x squared minus 1. Well, and this is where we have to remember our negative rules. A negative to an even power becomes positive. Same here, this would become positive. So we actually get the exact same thing. So g of -x would be the same, so this is an even function. All right, with our next example, again, we're going to plug in that -x. And then we just have to simplify. Negative raised to an odd power would be negative, so this would become -2x cubed, and this would be -3x. All right, I can take out my negative, and it just makes my whole function be the same now as what I started with, which is the definition of an odd function. All right, so that's the difference between even and odd functions. All right, so today we covered going over zeros, increasing and decreasing, and even and odd functions.